Hi guys, my name is Yunfeng Shao. This video is for my EL6825 pattern recognition course project presentation. My project topic is automatic number plate recognition using MATLAB. In this presentation, I'm gonna talk about how I achieve this topic in MATLAB using the existing algorithm available from the internet. And then I will compare some other approaches to mine, talk about the advantages and disadvantages. So first, let's see what is automatic number plate recognition. ANPR is a technology that could detect the car under the surveillance area and automatically read the plate number of the car. So how to build a system like this? The ANPR system consists three major parts: plate region extraction, character segmentation, and optical characters recognition. The plate region extraction includes two sub-modules, which are image pre-processing, plate localization, and extraction. So the original image captured by a camera is imported into the system. The first operation is pre-processing, which is in order to obtain an image that more suitable for the following steps. After that, the system locates the plate region. Then the plate image is sent to the character segmentation module. And finally, we do the characters recognition process. Now let's see the details of each part, how they can be implemented in MATLAB. First, it's the plate region extraction, which is the most important and difficult part among the whole system. It can be divided into several steps. We first roughly locate the plate region based on the color information. My program is designed for those family-owned cars with white characters and blue plates in China. So we can use this feature to locate the plate. But here comes a problem. When there are other blue regions except the plate appear in the image, for example, the car is blue, the system would have some problem locating the plate region. My solution is to take the length-width ratio and blue-white ratio into account. Eliminate the irrelevant blue region. This is the original picture, and this is the picture we get after the first step. Okay, the second step of plate region extraction is we have to transform the color image into grayscale image. This because we can then transform it from grayscale image into binary image for future processing. Okay, next, we find that the plate image cannot always be horizontal because the angle between camera and car. This can lead to mistake to the character segmentation and recognition. So in this program, the return function is used to adjust the image distortion. After adjusting the image angle, we have to convert the grayscale image to binary image and perform morphological operations to get a high-quality binary image for future usage. These operations can be achieved by the functions available in MATLAB Toolbox. Here's the results by each step. Notice that there are still some small irrelevant spots in this figure. So I use the area open function to eliminate them. In the last step, I inverse the binary image to get black characters and white background. Finally, we can get the exact plate region. I call this step accurate play extraction. The principle is setting the image center as the origin point. Scan upward and downward. Then we can find the exact edge of the play region. Check this picture. The result is very good. After play extraction, we come to the character segmentation. There are several ways to achieve this, but since the space between each character is big enough, we simply operate vertical projection of the binary image and measure the peak value to find a reasonable height-width ratio. This ratio can be acquired from the real plate. The problem is in the Chinese plates, some Chinese characters are not continuous. To deal with this problem, the system compares the width of a single character to the width of the whole plate, and then combines the mistakenly segmented sections. Okay, we've got the segmented characters. The only thing left is to do optical character recognitions. The simplest way is using template matching. Since the plate characters have fixed style and size, template matching is a very efficient method. The only problem is that some characters are very similar. For example, D and 0, B and 8, Z and 2, which can confuse the program. The way to avoid this issue is to design a more accurate set of templates. Okay, now it's time to run our program in MATLAB. I've already opened the program. Just click the Run button and choose the pictures. And okay, you see the program is very fast. Almost in a second, the result comes out. Let's back to the slides. To evaluate the program, I've had two tests. In test 1, 24 pictures are taken from straight ahead as the samples. The pictures may not be horizontal like these two. The test result is shown in the table. I have 87.5% accuracy, which is quite good. For the samples being recognized incorrectly, number 5 being read as letter G appeared twice, and the letter D being read as number 0 appeared once. In test 2, the sample pictures are taken from an oblique direction like this. From the table, we can see that when the input images are not taken from straight ahead, the recognition accuracy drops incredibly. Only 50%. The possible reason, I think, is that this angle cannot be corrected by random transform. The characters imported into the OCR module are oblique. So, this ANPR system has limitation of the direction from where the input image are captured. As I mentioned at the beginning, there are several ways to approach each part. Here I list some of them. For the play localization, I use color extraction, which is accurate, efficient, and easy to implement. But when the background has blue color, this method doesn't work anymore. We can also use edge detection for play localization. It's still valid when the car is blue. However, it is more complex to design. For the character segmentation, I use vertical projection, which is also very efficient. But when the Chinese characters have left and right toolpaths, mistakes may appear. The template matching method can deal with this problem, but it needs the plain image to be very standard. It can't stand any distortion. Last, for the OCR part, there is another approach called neural network. It's more accurate for those complex characters, but also takes more work to design. Okay, a quick summary. In this project, I implement the ANPR system using MATLAB. The system has a great recognition accuracy. However, it's designed for Chinese plates with white characters and blue plates. It highly depends on the input image color. It can be used for plates in other countries, so it still needs to be improved for practical usage. More simulations need to be implemented to get a more accurate value in the codes. Also, the algorithm has to be modified. Maybe I should combine different methods together so the system would be effective in different situations. Okay, that's all. Thank you for watching.